Today we're going to be reviewing sections 3.4 and 3.5. So we are going to use properties of special segments to solve problems. We're going to use auxiliary lines and proofs, and we're going to talk about overlapping triangles and proofs. So let's take a look at this first example. I would suggest that you sketch the picture. We are given that AC is an altitude. So remember, that is a special segment that we defined back in section 3.4. An altitude starts at a vertex and is perpendicular to the side that is opposite that vertex. Notice that AC, well, A is the vertex because it's starting at that angle. Perpendicular means that down at C, it's creating right angles. So I can mark that in my picture. They are asking us to find the measure of angle D. So notice that in this picture, I've given us a 52-degree angle over here at the angle CAD. So that means that we really have enough information just to focus on this triangle. Because we have 3 angles of a triangle, and I already know the measure of 2 of the angles, we are going to be able to find the measure of angle D. 3 angles of a triangle will always add up to 180 degrees. So 3 angles of a triangle add to 180 degrees. That will always be the case. And so because I know that I have a right angle, which is 90 degrees, and I have a 52-degree angle, I can then subtract both of those from 180, and that will get me the measure of angle D. So 180 minus 90 minus 52 is going to get us our answer. Well, 180 minus 90 is just 90, but 90 minus 52 tells us that we have a 38-degree angle, and that's our answer. Let's take a look at this one. It says that the line DE is a perpendicular bisector of the segment AC. So I would highly suggest that you sketch a picture. And then because we're talking perpendicular bisector, there's 2 vocab words, which means there's 2 different things that we're going to be able to mark in our picture. Perpendicular means that we're forming right angles. So if DE is perpendicular to AC, notice that it's right here at where D is, that it's creating these right angles. But it's also a bisector of the segment AC. So if AC is being bisected, that means that it's being divided into 2 smaller congruent pieces. So AD and DC get to be marked the same. The rest of the givens say that the segment AD is 2y plus 4. Segment CD is y plus 12. And the measure of the angle ADC, which is this angle right here, is 5 times the quantity x minus 12. They want us to find both x and y. Well, there's only one expression for x that is representing an angle. The angle, we also know, is a 90-degree angle. So if we have an angle that is represented with 2 different things, that means we get to set those 2 things equal to each other. So I'm going to distribute the 5, and that's going to turn that into 5x minus 60, still equaling 90. Now I can start solving for x. I'm going to add the 60 to both sides. That gives me 5x to equal 150. And then I'll divide both sides by 5, and I'll get my answer, x equals 30. So there's one of my answers. I solved for x. Now I want to solve for y. Well, I have 2 different expressions for y. They're segments that in my picture I know are congruent. So I get to just set those 2 equal to each other. So 2y plus 4 equals y plus 12. I'm going to get the y's to the same side. And then it looks like the last thing I have to do is subtract the 4. So that gives us y to equal 8. And so since we solved for both x and for y, we are done. All right, let's look at a proof. So sketch the picture because we're going to be marking up the picture. We're also going to be numbering our steps. So I'm going to start with my first step as my first given. Point G is the midpoint of the segment DE. That's given information. That given information is with a vocab word. And so because we're dealing with a midpoint, we get to expand on that. If G is the midpoint, it's then creating two smaller congruent segments. Those segments happen to be segment DG and segment EG. So I get to say that those two are congruent. Now remember, it's an if-then sentence. The if is what's given, the then is what we are concluding. So if a point is a midpoint, because that's what was given to us, then it divides a segment into two congruent segments. And that's what we were concluding. So I'm going to mark that in my picture. I'm not going to be able to expand on that any further. So I'm going to move on to my only other given, that the segment, DF is congruent to the segment EF. So DF and EF, I'm going to give 2 tick marks. All right, that's all that I can state there. We are trying to prove that the angle FDG, which is this angle right here, is congruent to the angle FEG, which is this angle right here. So in order for that to happen, we are going to have to get congruent triangles first. Unfortunately, I see 2 triangles, but hopefully you notice that those 2 triangles are definitely not going to be what we're going to prove congruent, because the triangle FDE is inside of the triangle of CDE. So there's no way you can have those 2 being congruent if one is inside the other. So how am I going to then focus on creating 2 triangles? Well, as long as we have 2 points, I can always connect those points to form another segment. Hopefully we understand that I'm probably going to want to focus on the smaller triangle that is inside, because that's where I already have some markings, and those are the angles inside that I want to prove congruent. So notice that we can draw in the segment FG. Notice from F, I can go down to G. Why can I draw that segment? Well, remember, 2 points determine a line. We call those the auxiliary lines. Remember, we can sketch in a line, but we have to state it in our proof. And now that we have that, hopefully we understand that we can say that the segment FG is congruent to itself because of the reflexive property. That then gives me 2 smaller triangles with 3 sets of markings. So I can say that the triangle FDG is congruent to the triangle of FEG. And if we look at the markings, that's because of side, side, side. So where was my first set of congruent segments? Well, that was step number 2. Second set of congruent segments, step 3. Last set of congruent segments, step number 5. And now that I have that, I can go to what I'm trying to conclude. I'm trying to conclude that I have those angles congruent. Well, those angles are inside of the triangles that we just proved congruent. And so any other pieces of those triangles are congruent because of CPCTC. Corresponding parts of congruent triangles are congruent. All right, take a second, sketch this picture, and then we will solve this proof. So we are starting with our first given, that the segment JH is congruent to the segment KH. So those each get a tick mark. I can't expand on that any further, so I'm going to move on to my next given, that the segment HG is congruent to the segment HM. So that's this one. Can't expand on that any further, so I get to move on to my next given, that the angle 5 is congruent to angle 6. Okay, we are trying to prove that the triangle, so here, let me highlight it, triangle JHG is congruent to the triangle of KHM. So remember, in order to prove congruent triangles, we have to have 3 things marked in our picture. If I look at the triangles that I just highlighted, I only technically have 2 things marked in each of those triangles. Notice that angle 5 is not the entire angle of the triangle that I highlighted in yellow. Angle 6 is not the entire angle of that triangle that I highlighted in green. So we cannot just go to what we are trying to prove. We have to think about another step. Notice that the angle that I want in the yellow triangle is bigger than angle 5. The angle that I want in the green triangle is bigger than angle 6. Notice that both of the triangles that I have highlighted seem to share an angle. They share this angle of KHG. So how do I go from something small to something big? Well, that's the addition property. So I'm going to say that the angle JHG, which is inside of the triangle, is congruent to the angle KHM. And like we said, that's something big. To go from something small to something big, it was the addition property. So I'm taking the congruent angles that I started with, which was angle 5 and angle 6, and I'm adding on that single middle angle that they shared in common, which was the angle KHG. So angle 5 plus angle KHG gets me angle JHG. Angle 6 plus angle KHG is going to give me the angle KHM. And so now that's this angle. I'm running out of spots to. All right, so now I do have 3 things that are marked in my picture. So now I have enough to go to what I'm trying to conclude, that the triangle JHG is congruent to the triangle KHM, and this is because if you look at the markings, side, angle, side. So my first set of congruent sides came from step number 1. My angles, remember, did not come from step number 3, but came from step number 4 when we had to add pieces together to get the angle inside the triangle. My other segment was back in step number 2. So that's us looking at special segments, drawing in lines, so auxiliary lines, and looking at overlapping triangles.